That's right, students. Miss Dalton's back in this video, so let's go ahead and get started. So we're going to talk about linear story problems today, and for this you need to know what the difference between independent variable and dependent variable is. An independent variable is just the x variable, and sometimes, well, all the time, it's going to be the very first thing that happens. So that's how you can remember it. It's the first thing that happens that makes something else happen. So the first thing that happens. Okay. The dependent variable is your y variable, and it's what happens after the independent happens. Okay, so how you're going to do this is every time you read a story problem, you always want to identify the dependent and the independent variables using x and y. And like I said, you can sometimes think of x as the first thing that happens. So we're going to put that in here, the first thing. And I'm running out of room, so let me scoot over. So the first thing that happens. Okay, and because y can't be determined until x happens. That's why we say that y depends on x. Of course, this won't work in all situations, but maybe it'll help you if you get stuck. So let's look at this first problem. We're just going to identify the independent and the dependent variable. So it says the amount of time it takes you to get home from the football game and the speed you drive are related to each other. So what depends on the other? Well, in this particular situation, I would say that the time it takes you to get home from a football game depends on the speed you drive. If you're going to drive slow, then it's going to take you a long time, but if you drive fast, it's going to take you less time. So in this particular example, the speed is going to be the independent, and then the time to get home will be your dependent. Okay, in this next example, it says how hard you hit your thumb with a hammer and how badly it hurts are related to each other. Well, how hard you hit your thumb is going to determine how bad it hurts. So the how bad it hurts depends on how hard you hit your thumb. So the strength at which you hit your thumb should be the x value, and then how bad it hurts would be the y value. Again, y depends on x. So if you think about it, just always read it back to yourself and make sure it makes sense. How bad it hurts depends on how hard I hit my thumb. And that is a true statement. Okay, so let's move on to this next one. It says there's a relationship between the position of the speedometer needle and how fast the car is going. There's a relationship between the position of the speedometer needle and how fast the car is going. Okay, so how fast the car is going to be your x value, and the position of the speedometer needle would be the y. Okay, and now just say it to yourself and make sure it makes sense. The position of the speedometer needle depends on how fast the car is going. And I believe that makes sense. Okay, I want you to try this next one, number 4, and just pause the video while you try it and then press play again when you're ready to check your answer. Okay, hopefully you got the X variable to be the size of the diamond engagement ring, and then Y to be the cost of the ring. Again, the cost depends on the size of the diamond. Okay, the next problem, we're going to fill out some more information. The problem says, as you drive home from the football game, the number of kilometers that you are away from home depends on the number of minutes you have been driving. Assume that distance varies linearly with time, and suppose that you are 11 kilometers from home when you have been driving for 10 minutes, and 8 kilometers from home when you have been driving for 15 minutes. So the first thing we're going to do is we're going to define the variables. So in the first sentence it says the number of kilometers that you are away from home depends on the number of minutes you've been driving. So the independent variable is the time that you've been driving. And then the dependent, so what depends on the other, is the number of kilometers you're away from home. So I'm going to call that the distance away from home. And out beside that, I'm going to put that it is in kilometers, just in case we have to do any changes in the units. Okay, so we need to find 2 points. Well, they give that to us. They say that when you're 11 kilometers from home, you've been driving for 10 minutes. So since we have the X value being the time that we've been driving, then our first ordered pair is going to be 10, 11. Our second ordered pair comes from the next statement. It says 8 kilometers from home when you've been driving for 15 minutes. So the 15 is going to come first, and then the 8 will come next. Okay, it says decide a reasonable domain and range. Well, the domain is our X values, so we want to keep in mind that that is the time that we've been driving. And when you have time, you can't have any negative time. So where it's going to start is at 0. We're going to write it as an interval. So the domain can be from 0 to really infinity, because we could keep driving and driving and driving forever. Now the range, what is our range? Well, our range is our Y value, which is our distance away from home. So again, we could be 0 distance away from home. That would be when we were at home. So that is going to be included, but we can be as far as we want to be from home. So it's from 0 to infinity as well. Okay, and here they're wanting us to sketch the graph. So on the x-axis, we're going to label that as time driving. And in this particular scenario, we're counting the minutes that we've been driving, so I'm going to put the units there. And then for the y value, that is the distance from home. So I'm just going to put distance from home. And I'm going to put over here, because I've run out of room, that this is in kilometers. So we're going to sketch the graph. Well, the time that I'm driving and my distance from home, so we're going to say that 0 distance from home would mean that we're at home. So if I'm away from home, it says that the distance varies linearly with time, so we know it's going to be a line. But we could go ahead and we could plot these points just to get an idea of what our graph is going to look like. So when we've been driving for 10 minutes, So I'm gonna label this by fives. So this is 5, 10. Should do it in a different color. And then over here is going to be 15. So this was 10, 5. Okay, and so at 10 I was at 11. I was 11 away from home, so I'm going to go by fives here too. 5, 10, 15. So at 10 I'd just be a little bit up here. And then 15 would be at 8, so that's going to be getting closer to home. And so my graph is going to look something like this. Again, it is going to be linear, so we want to try and draw a straight line. And we're just sketching it right now. And then it says find the particular equation that expresses distance in terms of time. So we're going to use these points right here, 10, 11, and 15, 8. First thing that we want to do is we always want to find our slope. So we're going to subtract our y's, so 11 minus 8 on top. Our x's on bottom, so we're going to do 10 minus 15. 11 minus 8 is 3, and 10 minus 15 is negative 5. So our slope is a negative 3/5. And then if you remember, we have to use the point slope form to get our equation. So y minus y1, so I'm going to put 11 in, equals our slope, which is negative 3/5, and x minus 10. And if you've forgotten that form, please look back in your notes from Unit 1, and you'll be able to see that form there. And now we just need to get y by itself. So we're going to distribute. So we have y minus 11 equals negative 3/5x, and that would end up being a positive 6. And then you add 11 to both sides. Alright, so our final equation, I'm going to write it over here, would be y equals negative 3/5x plus 17. And that would be the equation. Now we could go ahead and we could put in our d and our t in place of the y. So if that's what we're going to do, let me erase the y and the x. And let's put in, for our y, that's our distance, so we're going to call that d. And then our x was our time, so we're going to call that t. Okay, we're going to keep going with this problem, and I've written the equation up here at the top so that we didn't have to flip back to our previous page. So we have this equation, and now it's asking us to predict the distance from home when you've been driving for 20 minutes. So the 20 minutes is our time, so we're going to put it in place of our equation for t. So the distance is equal to negative 3/5 times t, which we're going to put in as 20, and then plus 17. Okay, so go ahead and figure out what that is. This is going to give you negative 12 plus 17, and so it looks like they're going to be 5 kilometers from the house. Okay, when were you 7 kilometers from home? So the 7 kilometers represents the distance. So we're going to put that in for distance. So 7 equals negative 3/5 t plus 17. And so now we just have to solve for t. So we're going to subtract 17 from both sides. And that's going to give us a negative 10. And that equals negative 3/5 t. Okay, well, in order to get rid of the negative 3/5, you can't divide by a fraction, so what you're going to do instead is multiply by the reciprocal. So I'm going to write that right here. The reciprocal would be a negative 5/3, so I'm going to multiply both sides by that negative 5/3, and that's going to make these cancel, and so you'll have t equals, go ahead and multiply that out, and that comes out to be 50/3. So if we go ahead and we divide 50 divided by 3, that would be 16 2/3. And of course that would be the minutes. So that's how long you'd been driving. if you're 7 kilometers from home. Okay, in part H it says, what does the distance intercept represent in the real world? Well, our distance is our y, so they're really asking us what the y-intercept represents in the real world. So if you remember a graph, our distance is going to be up here somewhere. So what does that intercept represent? So if you remember, that's going to be the distance when the time is 0. So you just write that out. It is the distance away from home, and you can either say when the time is 0 or when I first start driving. Okay, part I, it says, what does the time intercept represent in the real world? So we've got our graph here, and if you remember, the time is down here, and so this would represent when the distance is 0, how long I've been driving. So it represents how long I drove to get home. And that would work. Or you could say it represents how long I drove when I arrived at home, or when the distance from my home was 0. Okay, and the last question, I want you to go ahead and answer this and fill it in on your whisk. It says, what does the slope represent in the real world? So if you'll answer that, and I will see you guys tomorrow. I hope you enjoyed me being back and doing the videos.